Hi everyone, welcome to CodeTav management. So today we will solve today's Geeks for Geeks problem of the day, which is code schedule. So the question is there are a lot of n tasks you have to pick labeled from 0 to n minus 1. Some tasks may have prerequisite tasks, and for example to pick task 0 you have to first finish task 1, which is expressed as a pair 0, 1 given the total number of n tasks and a list of prerequisites pair of size m. So find the ordering of tasks you should pick to finish all the tasks. So there may be multiple correct orders. So you just need to return any one of them. So if it is impossible to finish all tasks, return an empty array. Driver code will print no ordering possible on returning an empty array. Returning any correct order will give the output as 1. And whereas any invalid order will give the output 0. So here n is 2, m equals to 1. So prerequisites is 1, 0. So output is 1. The output 1 denotes that the order is valid. So if you have implemented your function correctly, then output would be 1 for all test cases. One possible order is 0, 1. So example 2, n equals to 4, m equals to 4. So 1, 0, 2, 0, 3, 1, 3, 2 in this way. So output is 1. There are a total of 4 tasks to pick. To pick task 3, you should have finished both task 1 and 2. Both tasks 1 and 2 should be picked after you finish task 0. So one correct task order is 0, 1, 2, 3. Another correct ordering is 0, 2, 1, 3. So you can pick the 1 after 0 or 2 after 0 in this way. So returning any of this. So here 3, 1 is also possible, 3, 2 is also possible, 1, 0 possible, 2, 0 possible. So it's okay. So for that reason, any of this order will result in an output of 1. So your expected time complexity is big O of n plus m, and space complexity is big O of n plus m. So we can implement the depth first search here, right? So here this class solution is there. So I'm explaining this one. So yeah, so this is the class solution, and after that this DFS method. So this is declares a static public method which is DFS. So this method performs a depth first search to detect the cycles in a directed graph, and it takes an adjacency list. This is ADJ list, and the number of courses, this one, and then the index, current index, and array to track visited nodes for this visited, and then an array to track the nodes in the recursion stack. So this is recursion stack, and a stack to store the topological order. That's why taking this topological stack. So after that, this marks that the current node is visited, and this denotes that the current node as part of the recursion stack. Okay, so after that we are iterating here through the neighbors of the current node, and then we are checking that if the neighbor is not visited, then it recursively calls the depth first search method on that neighbor, and then boolean is cycle. So it's checking, means if there is a cycle in the subtree rooted at the neighbor or not. So if cycle is there, so if cycle is detected, then it immediately returns the true to indicate the presence of a cycle. Otherwise, it is going to that else if. So if the neighbor is already in the recursion stack, so it means there is a backage indicating cycle. Then this marks the end of the recursion for the current node. And after that, we are pushing the current node onto the topological stack. And next, let's look for the and lastly here we are just returning false to indicate that no cycle was found in the current subtree. So next, look for the get adjacent list method. So this is that method, and here basically it declares a static public method which is get adjacent list, So this method creates an adjacency list represented of a directed graph, and after that it initializes an array list, which is ADJ list, to store the adjacency list, and the size of the list is set to the number of courses. So after that, we are iterating. So here we are initializing each element of the adjacency list with an empty array list, and after that we are populating the adjacency list based on the prerequisites. It adds directed edges from the prerequisite course to the course that depends on it, and finally go to this find order method. So here we have declared a static method, which is this find order method, that returns an array representing the topological order of the course. So after that, we are doing this boolean visited new boolean in. So this is because of it's initializing an array to keep track of visited nodes during the DFS. So after that, this boolean rec stacks. So this initializes an array to keep track of nodes in the recursion stack during the DFS. After that, we are just initializes a boolean variable to check whether a cycle is detected or not. Next, we are initializing. We are just initializing a stack to store the topological order of course. So after that, here through this, we are just creating an adjacency list from the prerequisites, and after that, here we are performing the DFS traversal on the graph for each unvisited node. So if a cycle is detected in any connected component, this is cycle is means this is cycle variable is set to true, and if no cycle is detected, so if no cycle is detected, then it means that valid topological order exists. And after that, we are returning the course order here. So after that, we are just returning the array representing that topological order. And specifically here, we are just populating an array course order with the topological order by popping the elements from the stack. And after that, here we are just returning the array representing the topological order. Otherwise, we are going to this else condition, means here if a cycle is detected, then it's returning an empty array, okay, to indicate the impossibility of forming a valid topological order. So this is the solution here. So I'm just running it. So compilation completed, then submitting it. But before that, all test cases passed. Okay, I will check that one. If you will want to put some input, then you also can uh, give your insights. Actually, here, this you can see that 23/1/2024, this Java code, all test cases passed through the same code, but don't know why it's not giving the correct output now. Means why all test cases not passing. So I will check that one. So I think there is some compilation, means there are some issue with the GFG. See, now check, all test cases passed. Okay, check that one. All test cases passed now. Okay, so sometimes it happens. So okay, just keep practicing and do like, share, and subscribe. Thank you, everyone.